Good morning, Jay Fisher with Gilson Engineering out of the Pittsburgh office. Here today to do a brief overview of the Banner Engineering line of wireless products. You'll recognize Banner's name. They have a long lineage within the photoelectric world as well as machine safety. In early 2000s, they came out with additional business units of both LED lighting as well as wireless. Now, Banner Engineering's line of wireless products can be had in two different flavors. Those flavors are both the 900 megahertz frequency as well as the 2.4 gigahertz frequency. The 2.4 gigahertz frequency in the United States today is a relatively cluttered frequency. This is due to wireless routers, automatic door openers, etc. So we generally tend to stick with the 900 megahertz. That buys us additional benefits in the sense that we can actually boost our transmit power up to 1 watt, which is the maximum allowable by the FCC in a license-free configuration. If you've had heartaches in the past with wireless HART or any of the 2.4 gigahertz communications, it's because you're limited on your actual transmit power. I think wireless HART offers something around a 65 milliwatt communication power compared to the 1 watt we're able to provide in the 900 megahertz configuration. As far as Banner's wireless I/O, basically what I'm doing is I'm taking field I/O and transmitting it back to a base radio that I can then gather into my SCADA or PLC. The master radio is called the gateway, and that can be had with a 485 output to my PLC, basically offering limitless field I/O to be brought into it. And as far as the field I/O goes, I could tie 47 field radios or nodes into that one gateway. I also have the ability to add additional gateways and additional wireless networks if my I/O density happens to be higher than what those 47 allow for. But the 47 generally tends to cover most applications we come across. Now, as far as the packaging of the radio is concerned, the standard Banner radio offering is a NEMA 4X or IP67 housing. This is the way the radio comes out of the box. It includes an antenna with it, so you could basically throw it in the field and be up and running same day. The housing includes dip switches that are used for node communication settings, as well as 2 integral push buttons and a display. The I/O density ranges in the 4 to 6 I/O range, both in and out, and those could be analogs, digitals, counters, or temperature. Banner also released a board level radio. The purpose of the board level radio is to cut the price per point down if you have a pre-existing field mount enclosure that you could put it in. I add my antenna with a little whip cable to get outside the enclosure, and I have a very low cost solution. We're talking sub $300 per point. One of the other things they've done is to include a battery in the housing. This allows me to basically mount a radio in the field with no conduit run. The battery actually powers the radio, but then I also boost this 3.6 volt lithium ion battery voltage up to 18 or 24 volts to actually run my field device. So I can tie this into a pressure transmitter and transmit a pressure back every 15, 30 seconds, and I won't have to run a single piece of conduit except between the radio and the actual field device itself. So Banner has also developed a hazardous area rated radio. It's a full metal enclosure, but it's an S.I.S. intrinsically safe radio inside it that can be coupled to an intrinsically safe field device for mounting in a Class 1 Div 1 or Class 1 Div 2 area. The radio actually runs on that same 19 amp hour lithium battery that the other non-hazardous radio we already discussed has. 19 amp hours in a, let's say, once every 5 minute, depending on what device it's tied to, but once every 5 minute pull rate, you can expect something like 2 years of battery life or 3 years of battery life in something like a float probe or a pressure transducer. And of course, with the battery management, the lower my pole frequency, the longer my battery life. So I can update that at once every 5 seconds, or I can update that at once every 4 hours, and it's up to you. The 19 amp hour battery is a commonly had, you can find it online, and a very low cost battery. Whereas if you're familiar with wireless HART, those batteries can get pretty expensive. We're talking in a couple of $100 range per battery. So it's quite a cost savings over some of the other technologies out there. Plus you do get that 900 megahertz, which eliminates or mitigates much of the issues of the 2.4 gigahertz wireless HART frequency. Now, one of the other things they've done is to combine a wireless node with a temperature and vibration sensor. The temperature and vibration sensor can magnetically mount right to the outside of a drive or a motor or a fan, and I can basically take my conduit-free, battery-powered wireless radio and do field surveys on my equipment in the field for PM's sake. Basically, walk up, set my vibration sensor on the motor, set this down next to it, and it'll talk back to my gateway and feed that information in my PLC, and that'll help me to plan for preventive maintenance. And that's a general overview of the Banner Engineering line of wireless products, and it's really just the tip of the iceberg for the applications that these wireless sensors can solve. For an application you may have in mind, don't hesitate to reach out to your local Gilson Engineering sales rep for an on-site demonstration. Or you could visit us on the web. Thank you for your time, and have a great day.